members of ACCE, academicians, department engineers, and student friends. Welcome you all. This topic is very important for all of us in civil engineering field. It helps us understand optimization techniques by selecting proper structural systems, learning about building structures, different construction methods, quality and risk management, planning techniques, advanced technologies for high-rise building constructions, various construction equipments, modern methods like upgrade technology. I'm sure today's session will help us all gaining knowledge and practical ideas of our professional expert engineer P. Surya Prakash Garu. Welcome you all. I request Dr. Badal Sundara Garu to invite today's speaker.
Good morning to all. I profoundly welcome all members and our beloved guest, Dr. Surya Prakash Garu, and other distinguished members, including Anchuri Garu. I welcome you all for this webinar. We are highly thankful to Surya Prakash Garu for accepting our invitation immediately and for making this presentation. Thank you, sir. And not mostly, this is my, as a chairman of Kakinada Center, this is the last webinar, and I am highly thankful to all members who have given their support throughout my tenure. Thank you all. And now I introduce Surya Prakash Garu. Engineer Surya Prakash is an eminent engineer, consultant, and a mentor who has made significant contribution to civil engineering. He obtained his bachelor's degree. Sir?
Video is off.
Video is off. Huh? Okay, I am. Yes, sir. Once again, I am starting. Engineer P. Surya Prakash is an eminent engineer, consultant, and a mentor who has made significant contribution to civil engineering. He obtained his bachelor's degree in civil engineering from JNT UK in 1986. He did MS in structural engineering in 1990 from IIT Madras. After working for 6 years as design engineer, he established Satyavani Projects and Consultants Private Limited in 1994. He is also the founder and mentor of Smart Infra EST, a trust dedicated to the civil engineering to enhance employability and employment. He was president of ACCE from 2013 to 15 and is founding president of PSI since 2013. Engineer Surya Prakash professional memberships are FIE, Fellow of ACCI, Member of ICI, Member of IRC, Member of IBC, Member of INSDAG, Member of IIBE, etc. He is elected council member of the Institution of Engineers in Civil Engineering Division from 21 to 25. And now again he is contesting for council member of IEI. I request all members and all friends to support him. During his tenure, he is working well for the engineers bill, and if we give him full support and if he becomes a member again, definitely this engineers bill will take place and it will be passed in the parliament. We have to support him, and I request all the members to give him a good support. And now coming back to his profile, he authored a book on design and implementation of communication towers. He has also authored a handbook on SOP for building construction published by CREDAI, Telangana. And during our one of the webinars, he has delivered one webinar on SOP for building construction for ACCE Kakinada also. Engineer Surya Prakash is a guest training faculty to CIRE ESCI Hyderabad on CAD of transmission line towers. He is the chief resource person for LEAP LEAP lectures in 56 topics for smart infra EST. The CapFAD software developed by him won the ACCE CDC Best Software Award in 2007. He also received Eminent Engineer Awards and President Medal of ACCI, IBC, iFocus, ECI, Vishwakarma, etc. He organized many workshops and conferences twice to 2004 PepsCon, A3 P10, MacCon 2007, EIA, IS 456 New Vistas, Seismic Design of Buildings, IS 1996, ISIS 1999. He was a member of the expert committee for categorization of seismic damage structures. He was appointed expert committee member by AP government for review of projects in irrigation, affordable housing and capital Amaravati works, totally costing about 1 lakh crores. Engineer Surya Prakash participated in several international conferences, to name a few: Singapore, Como, Italy, Seoul, South Korea, Precast Moscow, Singapore, SCWC, Istanbul, FIB Congress at Oslo, etc. He guided projects for MTech and BTech students of engineering colleges, IIT Madras, JNTU, NIT, etc. He is also involved in the training of about 10,000 engineers online during pandemic. His services during pandemic are excellent. Actually, he has delivered several lectures during that pandemic period, and all are very useful for civil engineers, particularly for budding engineers. Engineer Surya Prakash handled several prestigious projects during the past 3.5 decades. Some of the projects he undertook include affordable housing, residential, commercial, office, IT, industry, hospitals, hotel buildings, etc. Infrastructure projects like roads, bridges, metro rail, runways, hangars, logistic parks, leisure theme parks, stadiums, transmission line towers, FM, TV, microwave and cellular towers, etc. Providing architecture, engineering and project management services to the prestigious clients, including Ministry of Defence, state governments of Telangana and AP, IL&FS, Tech Mahindra, GVK, GMR, BSNL, Idea, Airtel, Tata, Saket, Manjeera, Janapriya, Ashoka, etc. It's a great privilege to introduce Surya Prakash Garu. I welcome Surya Prakash Garu.
Thank you very much, sir. So, shall we start, sir?
Yes, sir.
Yes, sir.
Please start, sir.
Yeah. Good morning, all my fellow engineering consultants, academicians, researchers, and students. It's my really happy occasion to address on behalf of ACCEI Kakinada Center. In fact, Kakinada Center is one of the closest centers to me because I studied there. And also, it's my privilege that today Dr. Badan Sundarrao Garu has introduced me. And it is the best introduction. I will definitely like to save this recorded introduction, because I have not come across such a best introduction anywhere. Because who else can introduce a consultant than his fellow consultant? So I'm very happy. Thank you very much, sir. I'm blessed actually today because of your introduction. And without losing much of time, I will get on to the topic of today, the design optimization of RCC buildings, planning and construction, basically. So I'll not focus on optimization of design, but design optimization of planning and construction. That's how I will frame it today, and mainly focusing on RCC buildings. And so the overview of my topic will be introduction to the topic, about RCC buildings, design optimization. I'll briefly touch upon what all I'll address today, and planning, construction, and finally conclude the topic today. So construction demand for buildings, as we all know, is growing rapidly. In Hyderabad alone, because I'm in Hyderabad, I can tell you about 5 years back, if there are 2 lakh flats to be constructed in a year by the builder, today it has grown to 5 lakh flats in a year. And coming to our projects also, if you see, the size of the projects, earlier we used to do 1 lakh square feet apartment building is a very big one those days, about 15-20 years back. But today, 4 million square feet, 6 million square feet, 20 million square feet are the typical sizes of the projects we are handling. So that itself talks about construction demand for building. And so we, the consultants, engineers, have to brace up to meet this demand. And at the same time, the demand for cost optimization also is growing because of the resources, paucity of resources, and we have to optimize the resources and optimize the technology introduction, and we have to utilize the advancements in the technology to achieve this timely completion. In fact, we had to complete a project of 3 million square feet in 12 months, 11 floor project. So, 180 rupees. Delivered such projects. So, I'll be sharing some of my experiences of such projects. This availability, as I already mentioned, whether it is aggregate, cement, or steel, we have to utilize very optimally. And design and planning techniques I'll touch upon today, and optimizing the construction for time, cost, quality, and safety finally. Of course, buildability. Buildability is also very important in terms of deliverability of the projects. So with this brief introduction to the topic, I'll get on to my thing. And the built environment, as we all know, is spreading everywhere in the globe, and scale of the projects and rapid growth. I must share, actually, I attended a FIB Congress in Oslo about 3 years back, and we presented the construction scenario of India. Out of 42 countries, India stands at the top, actually, whether it is in terms of volumes, quality, or complexity of the projects. So we engineers from India have a big responsibility. How fast they are doing, and mechanized and engineered construction. Mechanized and engineered construction is nothing but, whether it is farm work, whether it is preparation of concrete, production of concrete, or placing, transportation of the concrete, is all engineered construction. And ultimately, time, cost, quality, safety, and delivery is all required to be considered in our project consultants. This is just one of the complex project that we have designed. Ramanujacharya's statue in Vijayawada. Of course, it's not yet constructed, but we have designed this as a concrete structure. What is available in Hyderabad now is a bronze and brass statue, cladded statue with a steel structure. This we have analyzed and designed as a concrete structure using the BIM model. And also, this is the project we did in Aurangabad, a master plan, central business district for Delhi-Mumbai Industrial Corridor. So it iconic tower you can see, and a convention center, all mixed development, administration office, and hospitality, like service apartments, hotels, all in one place we had to design. just I'm showing as an introduction to show what kind of demands we have from the clients to deliver with the quality and economy. So coming on to the core of the topic, any design to be perfect, to be optimized, investigation is the most important thing, as we all know. And topographic survey, it starts with, it's not geometric survey or just survey. Topographic survey, many projects I come across survey drawings supplied by the client where a lot of missing information will be there. So we have to encourage our fellow consultant to conduct this topographic survey with all the details, including, if possible, chartered utilities on the ground. And above ground also, the transmission lines or distribution lines, water supply pipeline, all the details, not only in our site, but the surrounding, because it affects the design. And when it comes to larger projects, geological survey is also very important. Particularly, we have seen the problems of earthquake because of lack of proper geological survey or interpretation of the geological survey. Next is the geotechnical investigation. It's not a soil investigation. It is a geotechnical investigation. We have to ask for, and we should know we should also follow the code guidelines for extent of the geotechnical investigation and number of boreholes required and the type of test to be done on the samples. Because without this data, we will be doing the design, but after the design submissions, we'll have some changes that will be required from the actual site condition. So it is better we have proper investigation so that there are no changes during execution of the project. Next is the groundwater survey, feasibility of the groundwater, and groundwater table is another big thing. Material sourcing. This also we have to do the survey before even preparation of DBR, design basis, because material availability is a very critical thing, and we cannot change the design after finalizing the design because of lack of availability of material or escalation of costs of the material. Next most important investigation is the environmental studies. So we all know that any project of area, built up area more than 20,000 square meters, that means about 2 lakh square feet, including the parking, we have to have environment impact assessment report by competent authority consultants actually, and get the consent for establishment from the Pollution Control Board. So these are all the basic things before we even think of the design or before even we think of preparing design basis report. So this is about investigation. Next, geotechnical, when we talk about the foundation engineering. Nowadays, the ground improvement, we are doing some projects for these ports actually, where we have to design the pavement for keeping the all these imported containers actually. So if you see the CBR values typically near any seaport, the CBR values will be as low as 4 actually. So we cannot design the pavement with a CBR value of 4. So we have to go for ground improvements. And similarly, we have done a project in Cochin where the ground improvement is a must actually, including the use of porous vertical drains, PVDs. So next important thing is the slope stability, either in filling or in excavation. Checking the slope stability and designing the earth retaining is also very important before we go above the ground actually. So that's why I'm talking about geotechnical engineering importance when we talk about optimum design or design optimization in planning and construction. Next is the structural systems. I'll definitely go in detail about the structural systems because optimization depends on the structural system. And next is the design basis, partial safety factors. And we are going to get a revised IS 456, which will be based on performance-based design and also residual service life design. So these are very, very important factors in some of the projects. In fact, we were asked by the client to design the building to have a service life of 150 years. But if you see our IS 456 or even IRC, there are no perfect recommendations how to draft the design basis report for such service life. Next, coming to the design, the reliability studies in view of climate change affecting loads. This is very, very important. We all have K1 factor, we know, in our IS 875, which depends on the return period or probability of peak wind happening in the life of structure. Now we are seeing the rainfall we are seeing now this year. And also you must know that the rainfall intensity and the periodicity of rainfall has increased almost fivefold. How I am saying is, in the last 100 years, 1901 to 2000, we had 5 peaks of rainfall in 100 years. And in the last 25 years, we had 6 peaks of rainfall of 100 years. Similarly, wind speeds we have experienced in 96 and 2000 in the coastal areas. Also, in the last 2 decades, also 2 incidents of wind speeds exceeding our 100-year peaks actually. So this is the very, very important thing as engineers to incorporate for important structures, particularly the reliability study and proper reliability coefficient when we are designing. And next is the temperatures rising and the flooding happening yesterday in Hyderabad after 30 years. The central bus station CBS is flooded with the Musi flood action. Of course, multiple reasons, not only the rainfall, but we have to, as engineers, take into consideration the highest flood levels of 100 years and design the buildings actually and facilities. High strength materials, high performance materials. We are knowing now our friends have developed 180 M180 concrete actually, high performance and high strength, super high performance actually. And next is the rapid construction affecting shrinkage and creep. We also have to consider in design the speed of construction. Nowadays we are seeing the high-rise buildings of 40 floors in Hyderabad being constructed in 2 years, 24 months. And imagine the strength of concrete and creep of concrete. If you add 15 floors in 6 months, what will be the effect of creep in the structure? That also we have learned in Burj Khalifa kind of structures, the creep studies were carried out. And even in Hyderabad, when we did the first high-rise building, we had to consider this creep effects in the levels also. When we are marking and fixing the levels of the floor, we have to consider the creep effect. Next is our advanced tools like BIM, Building Information Modeling, virtual reality, and augmented reality. We should utilize, and we have using this Tekla, Rivet, and design, where we can eliminate a lot of changes that will be required in future because of the clashes of various services. The coordination of services, that is very, very important. It's not just the architectural plan, and we should not accept an architectural plan as it comes before we do the coordination with all the services and the structural requirements. So we as engineers have to study this interface of all the services and get the drawing finalized. Then only we should start the design. Otherwise, whatever optimum design we carry out will be subjected to revision. Now, the core of the topic, RCC buildings we are talking about. So, what kind of RCC buildings? And when we use RCC, we have to come out of that thinking that if we go for high-rise, we must use pre-stressed or post-tension or compulsorily use the technologies. Not necessarily. If you see the Burj Khalifa design, the tallest building, it is only RCC building actually. No high technology elements or materials, but definitely the best quality materials used in reinforced concrete and most optimum the structural system that was adopted. So it's very important as consultants for us to arrive at the optimum design. Think of built-up area, total built-up area requirement, number of floors that are to be constructed, and the basements required or not required. Nowadays, thanks to NBC, we are seeing the basements are not necessarily to be provided unless they are economical. I propose basements only in the soils where the top 10 meters is very poor soil. Then I utilize replacing the soil with the basement. Otherwise, in Hyderabad kind of scenario, where we have soft disintegrated rock or hard rock, we are proposing parking floors above ground only. And that will be definitely economical compared to cutting the rock in terms of time and cost also. And next is type of structures. That is whether it is a residential building, commercial building, office building. Nowadays, when we talk about the optimum spans that we are adopting, from my experience, I'm sharing. Actually, the span is decided based on the parking number of car parks requirement. This is very, very important point to be noted. And in commercial buildings, we are going for 8-meter span for parking, where we can accommodate 3 cars. That means I'll have 2.4 meters per car. So 3 cars is 7.2 meters. So if I can design the structure with 800 column, either circular or square or rectangle, then we can have 3 car parks. So that is the optimum span. And all the floors also will have the same span in commercial buildings. That is, I'm talking about where the car park requirement is nowadays is 40%, and in IT buildings, when it comes to office, the car park requirement is 60% of the built up area. That means if I'm building a 1 lakh square feet building for IT building, there I have to provide 60% car park. That means 60,000 square feet. So definitely car park will govern the span. And also office layout, when we make it, it will also help. The larger spans will give more flexibility to accommodate more people. And we all know nowadays the square feet per person. Earlier, I remember about 30 years back, we designed the first IT office building with 100 square feet per person. Now it has to 40 square feet per person. That is the optimum. Like you are able to accommodate more people per 100 square feet. That's how we have to look at when we talk about optimum. And office buildings, IT building, we have the optimum span of 11 meters with a flat slab or flat plate. Actually, we have designed many buildings, almost like 50 million, 40 million square feet of office with this kind of 11-meter span. 11 by 13 is the grid we follow for office buildings, but there we are not going for RCC. We are going for post tension. Even 8-meter span, if it is a flat slab, it's better we go for post tension slabs. And the post tensioning, many people are, even I used to think in the early days that post tensioning is a risky affair for fire. But I had a direct experience of fire accident in one of the building where we used the post tensioning in the bottommost floor. And after the fire, the entire cover concrete has spalled and reinforcement, bottom reinforcement is exposed, but the slab was safe, serviceable, even serviceable. And we could remove the slab because of the post tensioning. Then I changed my whole approach and I started using the post tensioning in most of the office buildings and commercial buildings where the span is more than 6 meters. It is better to go for. But I am designing one auditorium right now, where the span is about 20 meters, but cross span we have given about 6 meters, and we are not going for PT. RCC is found to be more economical. I'll give you more reasons of buildability also, because when we go for PT, auditorium means the roof level will be about 12 meters height. And in 12 meters height, if you have to do the post tensioning, you think of the scaffolding required. And you have to maintain the scaffolding from the beginning till post tensioning is done, and that final grouting is done for the post tensioning. Till then, we have to have the scaffolding. So, considering all these aspects, we found that RCC is economical at present building that we are doing. So, these are some of the experiences I'm sharing about optimum. Next is the structure. When it comes to the structural design, The frame, first and foremost, simple structure is framed column beam slab structure. And next, nowadays, we are seeing most of the high-rise building, we are using wall and slab. That means I don't call it a shear wall exactly, but it is a wall and slab, and technically to be called as a rigid monolithic construction. But in practice, many people are referring it to it as a shear wall construction or my-one construction. But the technical term is rigid monolithic construction. And next is the flat slab. Flat slabs that we use in commercial and residential building. I'll share some of the experience. And of course, we have shear wall. We use the term shear wall when we have the framed structure reinforced with shear wall for high-rise construction above 10 floors and up to 20 floors or 30 floors. Next is the shear core. Shear core happens naturally in the planning because of the service cores like lift or staircase, where we use the shear walls combined as a rigid monolithic, and it becomes a shear core, and very advantageous in terms of constructability and speed in construction also. I'll show some of the pictures for that in my as we move forward. Next is the planning. When it comes to planning, I already touched upon a little bit of planning, but statutory requirements, bylaws, particularly Andhra Pradesh now, if you see, a lot of amendments have taken place in the bylaws. So we have to be very thorough with those bylaws. Why I'm talking about is most of these things come on us because though we are the engineering consultant, client depends on engineers because most of the time we are connected with the project. Architects, once the approvals are in place, they're not so much connected as we engineers. So we have to be thoroughly, particularly about NBC provisions, fire safety norms, water supply, waste management, and not only structure actually, we have to be thorough with all these aspects when we talk about the permission. And timely completion is the most important thing. And when we are planning itself, we have to consider the time of completion of the project and start considering the structural system and design methodology, considering this. And finally, delivery of the project. This is the most important thing we do unknowingly from back of mind, but nowadays the clients are insisting that we take that responsibility of the delivery. So in the project, again, I talked about 3 million square feet, which was to be completed in 12 months at a cost of 1,280 rupees. I proposed 3 technologies in the same project, like conventional, precast, and rigid monolithic. The client was comfortable with conventional and rigid monolithic, but precast was, I'm talking about 2018. 18 year, the precast availability of vendors is not that much great in Hyderabad. But still, I assured my client that unless you use precast, you can definitely deliver this project in 12 months, that too at the cost. He was very skeptical. He took assurance from me, kind of affidavit from me, that in case the precast doesn't happen, I should see that I convert it into hybrid type of construction and do it. I agreed. But finally, the client was so happy we could deliver the project with the precast. And the client was asking me when I referred next project in AP to him with the total rigid monolithic, he was asking whether he can do combination. So that has proved my concept of mixed technologies or technology neutral in a project. So this is very, very important when it comes to delivery of the project. Next is the quality plan. Nowadays, we have to, I was in Mumbai day before and we were meeting with the client. Quality assurance plan, even before the project starts. We have to prepare the quality plan, and as engineers, it is our responsibility, material inspection, material quality, workmanship, and method of construction, everything we have to document and submit. And the next is the safety plan, because nowadays, we are talking about very high-rise constructions and complex. The safety of people, safety of structure is very, very important. And so we have to plan these things also along with the whatever structural system we adopt, whatever construction plan we make. So ultimately, construction engineering. This is the missing link among we engineers. Actually, I always say and love to repeat again that if any client says, I want a structural designer, if he says structural designer, I say I'm not a structural designer alone. I'm a civil and structural consultant. So that means I take care of the planning aspects of all these things I'm talking about. I'll take care of the waterproofing. I'll take care of the anti-termite treatment. I'll take care of excavation. I'll take care of structural system. I'll take care of the constructability, buildability. So there is no, if you are a structural designer alone, you just do the analysis, design and detailing and give the drawing. Maybe bar bending schedule and BOQ. That's all. But who will take care of all these things I mentioned? Constructability, which type of formwork, which type of construction technique, which type of concrete, whether it should be at the site or it should be, even before we plan the project, we should think of all these things as consultants. So only civil and structural consultant can think of all these things. So please, all of us say that we are civil and structural consultants, not just structural designer. And we know builders ask, what is the steel you give? What is there to give from my pocket, or am I a designer or consultant? We should discourage any builder or client talking about steel consumption per square feet. Of course, as consultants, we'll definitely optimize. There is only one single quantity that is possible, of course, if we do optimization. So as consultants, we should say that we will give you the best structural system optimum for your requirements. Give me the requirements completely, and I'll plan to meet and suit your requirement. So that should be our approach as consultant. Just I'm sharing as a fellow consultant my experience with my clients, and so that if it helps you in dealing with the clients, definitely the per square feet 2 rupees or per square feet 5 rupees will not be sufficient definitely to work as a consultant. So we should move to that. Next is the construction. Many advancements in construction, concrete types and curing compounds. We know curing methods. We have steam curing, we have heating heads, we have curing compounds, all these methods, and block work. Earlier, we were only dealing with the clay brick, but now we have block work. We have cement blocks, we have hollow blocks, we have terracotta blocks, we have so many AAC blocks, CLC blocks, all these, and different sizes. And I want to tell you and insist that please don't leave block work to the mason. Masonry is not mason's business. Yeah, masonry also is engineer's work, actually. So we have to engineer the masonry also. I have come across brick walls collapsing, actually. So we have to take care of that and consider construction method and time while deciding the block work and size of block and weight of block. Next is the method of top-down construction. Nowadays we have this, I will not go deep into that, though we have given a proposal for one of the projects including top-down construction. And excavation techniques. What method of excavation we follow in the project should be considered. Next is the deep foundations like piling. We have like Andhra Pradesh particularly, we have the longest coastline. And we need to go for deep foundations, particularly piles, precast piles. We have driven piles, board cast in situ piles, jetty piles, all this. And also we can use the micro piles, particularly for the existing buildings, retrofit if we have to do. Micro piles will come very handy. And micro piles can be used for small projects, actually. It is very advantageous, like 6-inch dia with a 32 dia rod, single pile, of depth about 6 meters, 7 meters for small building. We need not go for necessarily under-rimmed piles or necessarily, and we have done strip foundations on under-rimmed piles in AP in clay soils. So that is another optimum design we have done. And 2D and 3D precast construction is also gaining ground. In fact, I worked out on feasibility of 3D modular in East Godavari, because I'm talking to Kakinada engineers. We have even worked out on that. And rigid monolithic construction, that is my1 or shear wall, which is popularly known, and post tensioning and monostrand. Monostrand we have already used in one of the residential projects where the builder wanted 6 meter by 8 meter as the single flat without beams, without columns in between. So there to improve the speed of construction actually. Then when we go for precast, in fact post tensioning is not economical for 6 meter span as I said, but for this speedier construction and the lesser cost and lesser thickness of the slab, we had to go for post tensioning. But first time we have used monostrand and brought down the slab thickness to 150. If we design RCC slab for 6 meter by 8 meter two-way, the slab thickness will be 150. With RCC we can do with good quality control and this one. And the construction centering and proper quality of concrete. But we have used monostrand and reduced the reinforcement drastically, even in that 6 meter by 8 meter span with 150. Otherwise, if you go for post tensioning, the minimum slab thickness we all know is 180 mm because of the sheathing that we use and the size of the sheathing and cover to the sheathing. And formworks and stipping techniques, I'll also share that in my as we move forward. Ultimately, finishing flooring, the flooring methods. In fact, one project we have specified the structural slab itself as a finished floor because we had a height restriction in the building, and we increased the cover by 20 mm and insisted on finishing with a trowel structural slab so that itself is a parking floor I'm talking about. So like that we have done, it is possible. Next is the painting, joinery, mechanization, and the smart materials and the level of detailing 6, LOD 6 in BIM. These are all the things we have to consider in the construction planning actually. In construction planning means we have the crane position nowadays. We don't have project without crane, and because the labor costs are increasing. In fact, in 2007 I talked about this, that future will be mechanization in construction, and now we are experiencing no project without mechanization in material handling, material transportation, labor transportation, or even the total execution of the project. So LOD 6 in BIM will help us in planning the construction. Next is the building facade, plumbing, building automation, electrical, water supply. I will not go in detail, but we have to consider all these aspects when we talk about optimum design of the structures, whether it is loading aspects or clearances, ducts, requirement of ducts, particularly for the fire, and nowadays for the waste also, garbage chutes and all that. So water supply ducts, electrical ducts, building automation, everything we have to consider. Next is the waste management, as I said, site enabling. Nowadays, our planning we are modifying for facilitating construction also actually. So this is very, very important because construction cost is a major thing, and if we don't make the movement of material efficient, then the cost will go up. And labor installation and LILA, we call labor accommodation, and now the latest technology of 3D printing. Also, we have to think of in future for optimum design and planning and construction. This is the BIM 70. I was talking about LOD 6 for construction, and now 7 is for facility management. That is post occupancy future. It is going to be necessary for us. Pardon?
Oh, okay.
Now coming to the core of our today's topic, structural systems. So when we talk about, can we mute the people who are not participating in discussion? Organizers.
Muted, sir. Muted, sir.
Okay. Thank you. So structural system should be finalized through study of plan drawing and construction system. For the interest of our friends, I did one project with the BTech students in Hyderabad. What is the optimum span in an RCC building frame of steel plus 5 floors? This is the question, and we did the real study, parametric study, of the column beam slab system, and we found that 3.6 meter is the optimum span. 3.6 by 4, 3.6 by 5 can be the optimum. So we have to see that we will bring down the span to 3.6 by considering the plan and propose the framing to the planners, whoever is planning. So the framing system that we select should be suited to the building plan, and the selection of structural system is to be finalized with respect to cost, time, buildability, and functionality of the structure. I'm only telling what I have implemented. I'm not telling theory actually. I'll explain.
Sir, please unmute, sir. Sir, please unmute, sir.
No, request the organizers to unmute the speaker alone. And the rest of the participants, you can mute as well.
Yeah, I have done it, sir. I have done it now. Only thing is I have to share again. Share. Are you seeing my presentation now? No? I'm not getting the sharing. Oh, yeah. Oh,
సార్ అక్కడ హైడ్ ఆప్షన్ ని ప్రెస్ చేయండి సార్, మధ్యలో ఇంటరప్ట్ అవుతుంది స్క్రీన్ అక్కడ.
oh, okay, okay. Now?
థ్యాంక్స్ సార్. ఇఫ్ యూ నౌ యూ కెన్ ప్రెజెంట్ ద స్క్రీన్ డైరెక్ట్లీ టు PPT.
Are you seeing my screen now?
If it's visible, again you want to visit this WebEx form, then you can present the screen.
WebEx, huh?
Hmm.
No, are you seeing my screen now?
It's visible.
Yes, sir.
It's visible.
Structural system.
Yes, correct.
Yeah. Okay. Shall I continue?
Please, sir.
Yes, sir. Please proceed,
Okay.
sir.
Okay, thank you. So the selection of structural system should also be according to the type of soil and type of foundation used. Because as I said, the foundation, whether it is pile foundation or raft foundation or the piled raft or even the annular raft or strip footings, all will determine our structural system also, overall cost when we consider. Next is the load bearing and ribbed floor, RCC slab, column slab beam, framed diaphragms, and then column plate or flat slab system plate. Actually, I had a presentation. I am not showing now, but shear. Oh no. Can't we make one particular person mute, Durga? Whoever is disturbing, can we mute them?
Yes, sir. Yes, sir. I will.
Okay. Thank you. So column and shear wall and beam and slab and shear core, column frame and slab beam, rigid monolithic wall and slab system, PT slabs and high-rise system. So these are all the structural systems. I'm not talking about hi-fi structural systems. These are the simple structural systems that we are adopting nowadays for commercial buildings, office building or residential building. So load bearing is a simple thing. This is a load bearing infilled frame, I would say, which is good for seismic resistance also. And this is just a wall and slab, load bearing wall and slab system, which is still good actually, which is still economical, except for time and quality and availability of materials. IS 1905 is the masonry code. There are two codes for masonry. We have to use these codes, and of course, these codes require revision. So, but let's not forget that masonry wall also requires a proper design, structural stability for the masonry wall also. A flat plate floor system. In fact, I have done a project in UK where the floor height is 2.7 meters. Because of the heating requirement, if you reduce the volume, it is really very economical. So how can you bring down the floor height to 2.7? There, then strictly adopt flat plate only, no beams at all. No beams, no structural wall, only column and flat plate. Of course, it is possible in Britain, UK, because the earthquake is not very critical. In our country, earthquake is critical, so we have to be careful when we are adopting this. Next is simple construction, flat ceiling, reduced the finishing cost, and low story heights due to shallow floors. And I have seen in Europe some of the slabs without plastering, without false ceiling also. In a hotel, I have seen. And he has used the formwork, this plywood, which has given the finish as a texture actually. So that's really very good. We should adopt that kind of innovative things so that we can reduce the cost, improve the aesthetics, and also improve the performance. So low story heights due to shallow floors, and short to medium spans with light loading. We can use this flat plate, as I said, and also lack of earthquake. Flat plate with spandrel beam. That means outer we have the beam so that we can reduce the thickness, because we all know flat plate critical is punching shear, and punching shear will be critical in the edges because there is only 3 sides or 2 sides for resistance. So this spandrel will help in reducing wherever possible. Next is the flat plate with spandrel beam, increased gravity and lateral loads, increased torsional resistance, that is very, very important, and decreased slab thickness, as I mentioned. And same as flat plate systems, but shuttering for edge beams has to be taken care. Next is the flat plate with the beam floor slab system. That means we have a larger span, we use only flat slab, but we have the beams connecting the columns, and the gravity and lateral load frame, it will help. And two-way bending, increased gravity, and simple construction, flat ceiling. Next is the flat slab, which we all know very well as per IS 456. We have the drop panel, we have the column capital or column heads actually. So this will help in reducing the thickness, the drop panel. This again, as I said, when we go for 11-meter grids, this will help a lot. Flat slab system we found as most optimum. And for construction cycle time also, we have used the drop head shuttering system and table form. I'll show that as we move forward into the construction thing. And flat slab floor system, and normally we have designed for 8-meter span with 180 mm slab thickness actually, with the post tensioning. Very economical. We have done with 4 kg per square feet consumption, steel consumption with 180 mm with a flat slab. Next is the one-way joist floor system. This we use where we have one span larger and other span less, depending on the requirement of the client. Suppose you need 14-meter span instead of 11, and other span they allow us 6 meters. Then go for this kind of joist. In parking floors, it will help a lot. We have beautiful one-way joist. Means one-way joist is not steel or wooden. It will be concrete only. We design the joist as a joist, concrete ribbed floor actually. One-way joist floor system, and then we use it. Next is the two-way joist floor system. That is like a waffle. We all know when the spans are much larger, beyond 11 meters. Up to 11 meters, you can have flat slab with the drop panel and column capital. But when the span increases to 15 meters or 18 meters kind of thing, this waffle system will help a lot for the 15 by 15 kind of span. So we have used this also. So this is the waffle system. And nowadays we are using this plastic balls actually also instead of waffle. That is more economical. That is a biaxial slab system. Chiranjeev Rao, our friend, has been promoting that technology and very useful. So these are the solid slab with beams and solid slab with beams, and waffle slab with the two-way thing, and waffle slab with integral beam and ribbed. These are all the different systems that we can use for optimum design. And the rigid framed structural systems, this we can use, and this also, of course, you are all very experienced, but many people, I had doubt when I was doing my masters, how to model the foundation, whether fixed or hinged or partially fixed in our 3D model analysis. So my guide, Professor Arvindan, told me, I follow that every time. It is the rotation. Hinged means allow rotation. So in which type of soil we have rotation in the footing? The soils of sandy soils or soils with silty sand kind of soils will have rotation. So there we have to model it as a hinged. But when we are going for a foundation like raft or pile foundation or piled raft, we have to have it as a fixed, even though the soil is poor. So this is just for the sake of clarity. If I am not wrong, some of you may correct me. I can learn also. So this is the shear wall framed system where we have floors more than 10. In fact, in Gujarat post-earthquake, I visited and at least seen 100 buildings in distress. And of course, collapsed buildings, we don't bother. They collapsed anyway. So I found that most of the buildings with the shear wall were saved, though they are not designed properly for the earthquake proper design. So this is my experience. So shear wall helps a lot in lateral load resistance, whether it is seismic or wind actually. In number of floors more than 15 or even 10, more than 10, wind will become critical, more than earthquake actually. So we have to be very careful. We have to design for both wind and earthquake in all the projects, particularly Andhra Pradesh. Coastal districts, many districts fall in zone 3. So we have to be very careful. So this I just used building structures. Building structures, that means structure of a building. And building structures, that is, we are constructing the structure. So simple residence, if we have, we can see simple residence on the right side. I have shown 3D modular precast. You can just erect the building finished within a day. You order today, and in 2 days you will get the building. So this is actually, I was proposing this kind of solution for Indiramma houses and Jagan housing earlier. But the politicians or administrators don't like technological solutions because there is nothing to play around. So now that is happening. And mass housing is another thing which I'm showing on the top. We have done the projects of mass housing and high-rise buildings, auditoriums, stadiums, and indoor stadiums. We are doing one indoor sports arena actually, which is a hybrid like auditorium come sports, indoor sport. Amusement, hospitality, recreation, hospitals, and then office, commercial, warehouses, and data centers. Data centers is one big thing happening now, and we are seeing AP government also offering to Google biggest data center in Vizag. So we have to think of all these things, building structures for these requirements. And industrial buildings, I'll show some of the projects that we have done. Next, building structures, domes, folded plates, folded slab, frames, trusses, spatial trusses, shear walls, rigid monolithic core, modular structure. The right side we are seeing is a shear core with a slip form or jump form or moving form. You can see how quickly we can raise the structure, and around that we build the framed structure, whether it is RCC or steel. And voided slab co-biaxial. Yeah, this is the terminology I missed actually. I was telling the balls that we use, plastic balls or PVC ball, as a void in the slab, voided slab design instead of waffles. Tensile structure and then foundations, isolated raft piles, pile drafted. So this is about building structures and the construction methods, conventional formwork, acrospans, and adjustable prop supports, APS units. Docker, drop head, table form, tunnel form. I'll show these things which we have used. Actually, we have used all this in some of our projects. My one, or now we have aluminum formwork, engineered aluminum formwork. Even for normal construction, now we are using engineered aluminum formwork. Large panel, peri, skydeck forms, and slip form, jump form, climbing form, precast concrete, panel, battery mold, modular, and double T's, single T's, and hollow core slabs. And then upcrete. I'll show the pictures of upcrete, light wall panels, Ecotech. Now the partition walls, we are not at all going for, we are doing the Bombay project that we are doing, we are using Ecotech only panels. And in Hyderabad also we have Robomatic. Robomatic is a light wall partition walls, 75 mm thick also with the hollow core. And piling, pile driving, shore, we are doing pile driving, precast piles. In Vijayawada, I'm doing one project where we are using the precast piles. In Kakinada also, Reliance has used this precast piles driving. And Ongole, we have done one mall with these precast piles. Shoring piles, active anchors, passive anchor. This is for slope stabilization actually. Micro piles, sacrificial form, composite construction, speed flow is one of the type of systems for construction for large span. Top-down construction and PB, LGS, of course, today we are not talking. Next is the buildability assessment. Now we have come to the core, optimization. We have talked about structure, design, planning we talked, construction we talked. Now all this mixed, how do we assess which method to be used for given solution? Where do we optimize? What is that optimization? So that is buildability, cycle time for each floor, working capital, capital expenditure, mechanization, capital expenditure of construction actually. That means investing on formwork, investing on batching plant, all these things we consider when we are deciding the construction method actually. And next is the mechanization, material handling, feasibility, labor availability. This is the biggest thing. Here I must tell you one again my favorite project of affordable housing 12 months, where if I had done that project of 3 million square feet to be completed in 12 months, I assessed the labor requirement of 4,000 people to be installed near the site. And 4,000 people labor camp requires 30 acres of land actually. Imagine leasing 30 acres of land in Hyderabad city for labor camp for 12 months is a big challenge. So what we have done is by using these three technologies in the same project, we have reduced the labor requirement to 2,000. I'm talking about when I say labor requirement, it is carpenters, fitters, helpers, plumbers, electricians, masons, everyone. Total labor requirement. So we brought it down to 2,000 by using precast and rigid monolithic combination with conventional. And the labor camp land requirement has come down to 15 acres. And and also most of us ignore this fact. What is the cost of a labor camp? When we talk about optimum cost, labor camp cost also, we only consider the labor cost per head 500 rupees or 800 rupees, 1000 rupees like that. But the labor camp cost for a contractor is 130 rupees per head per day, apart from whatever we pay to the labor. So that also we have to consider when we are talking about optimization, including planning and construction. So land availability, risk mitigation, technology, and vendor availability. When we talk about technology, we also should think of vendor availability. If vendor is not available, can we build vendor? I did that also. Now we are doing a project in Indore where I am using precast, but there is no precast vendor to that scale. So I am mobilizing the vendor from Hyderabad or Chennai or other place to Indore who will set up the quick precast plant, like a mobile precast plant, which can be used for precast. So like that, we have to think of vendor availability and risk mitigation also. Risk mitigation means, suppose when we have seen in Andhra Pradesh also, suddenly government wanted to build 4.5 lakh houses within 1 year with all aluminum formwork. Imagine who will supply so much of aluminum formwork if you are doing everything in aluminum formwork. So that's a risk actually. The cost of aluminum formwork has gone up during that time. Whereas I could procure 9,000 rupees per square meter aluminum formwork, the contractors have procured aluminum formwork at 14,000 rupees per square meter. So that kind of thing. Next is the time management, importance of time in a project. It is desirable. Cost is related to time actually. So it is directly proportional. It will increase with the time. So we have to think of optimum timeline and then quality. But quality doesn't cost. My Guru Garu has said once. Does quality really cost? No, quality is a necessity actually. We cannot talk about optimization in quality, but quality management, with what systems we can achieve quality, is very important. Next, risk at construction management. Labor supply, we see most of the projects in Indian scenario particularly, every season we have some labor going for holiday. Like Dasara, for Dasara you see north and east, west guys, and we see Maharashtra and other people. So like that, we have this supply risk is very big thing, and structural steel supply erection, high-rise management experience is very, very important. Now, suddenly there is huge demand for high-rise building, but not so many available people are there. Purchasing, management staffing, that is very, very, I am struggling actually to get this management staffs. Engineers who can manage the project. Next is the construction planning, high-rise buildings. I think we are running out of time. I'll try to move quickly. Technologies to construct high-rise building, and then technologies to column wall proceeding method, various methods of construction. So, and with pictures we'll be able to do better. So auto climbing formwork, which I'm showing the picture, and safety platforms and walkways also important when we talk about formwork. And rebar prefabrication is very much available in Hyderabad. And now it is time we plan for this everywhere, in every district actually, of Andhra Pradesh also. Next is the rebar prefabrication. This is for piles, particularly in column. And then concrete pumping technologies, because when we talk about high-rise buildings, concrete pumping and boom placers are very important. And simple drop head formwork. This we have used almost like 20 years back, 24 years back. This first time we have used drop form to reduce the deshuttering time by at least 7 days. So actually in IS 456, if you see prop in position, you can do the stripping within 3 days. So we have used that prop in position. We have an extra set of prop and then use this form. So this is the prop is there in position, you are removing the form. So that's how we can do. And major equipment used for tower cranes, main hoist, and concrete pumping equipment. So this is the typical picture of site. And hoist, passenger and material hoist we are nowadays having, and also suspended rope platforms. Our friend Rambabu is supplying CMAC, very innovative material handling systems, and precast flat panel system like large panels in precast. This we have used in the project. 3D volumetric construction also, and next tunnel form in Hyderabad they have done, in Bangalore they have done tunnel form. The cycle time is 3 days actually. If my one cycle time is 7 days or 6 days, tunnel form is 3 days is achievable, but safety we have to take care. Flat slabs, this is the actual picture of the project I was talking about, 11 meter by 13 meter with a drop panel. And hybrid concrete constructions like use of precast. This also, in fact, in Vijayawada project, we are using a wall cast in situ, complete wall. It's a wall and slab system, and the slab we are providing corbel, and we are using hollow core as the slab. And for residential, we are using flat slab, flat plate, like a simple solid slab. Because residential, the spans are very less, we need not go for hollow core. So this kind of hybrid concrete construction also is possible. Pre-stressed concrete, of course, the walls, precast columns, and slabs, solid slab panels, and lift slab system. This is another for faster construction. So the slabs are cast, and without centering, you can lift the slab on the columns. And slip form construction, particularly for this, what you have course, we can use this slip form table form we have used in Pune in one of the office building, where you can achieve. We have done 2 lakh square feet in 3 months. The structure with a cycle time of 4 days for using this table form. So system column formwork. This also you can see these inclined columns and this type of column. Vertical panel systems. DOCA is very, very good for retaining walls and high wall systems actually. Next is the upcrete. This is what I wanted to share with you. I don't know how many of you experience when we do this wall and slab system, we see the air pockets in the vertical walls. Did we ever, and even in precast we achieve that, we get that kind of air pockets. The reason is, when we pour the concrete from the top, the air is entrapped in the concrete. That air has to escape and it doesn't find the place. So you will get the air pockets in the concrete. So this upcrete system was developed. That means you can pump the concrete from the bottom up. You can see the pipe here, step 3. Pipe is connected here and concrete is pumped up so that the air escapes from the top. So this is not a very new one. It's a 15-year-old. I'm trying to implement, but cost of it is very high. Formwork cost goes up. But wherever you need the best quality, you can use this upcrete technology. And we use this upcrete in 3D modular precast also, battery system. Aluminum formwork, you all know now, and we have done. I'll just show some of these projects. 11 by 15 meter span, 13 meter span, IT office. We did 2 million square feet, 14 floors within 30 months, this project. Telangana Secretariat, also we did the planning, and 7 lakh square feet. It is a flat slab system with shear core walls. And this is the dimensional symmetry of this Telangana Secretariat. And this is the total 3D model for analysis for this Telangana Secretariat we did. And augmented reality, it will save us a lot of time in site visits if we can implement in the project. Recyclable unique formwork. This is the invention recently in 3 years back presented in FIB Congress by Germans actually. That means the formwork used for this is sand with a chemical compound. And normally this kind of complex structures we don't plan because of the formwork cost. Here they found that they optimized the structure shape for most economical thing, and they use the reusable form. That means they put the sand, pour the compound into this, and after it sets, they will another chemical they will add so that the whole sand can be removed and the structure is formed. So very unique thing. And this is another large-scale housing we did in Bangalore, Chennai, and Hyderabad. And in Agartala, we did a IT office building. And this is that my favorite project of affordable housing in Hyderabad. It is no way in less quality compared to any builder project, but it is for really given by government to the poor people. So in this we have done 3 technologies, and after completion you can't make out which is precast, which is rigid monolithic, and which is frame. So 15 blocks are conventional and 14 blocks are precast, 18 blocks are ready mix concrete. So this is an interesting project we did, completed in 12 months, and contractor made profit in 1,285 rupees. 3D printing, and this is another project we are doing now, about 26 million square feet total in 100 acres, all 40 floors and 50 floors residential. One of the success. This is another completed project where we optimized the structural system, buttressed core, which is used in Burj Khalifa. In fact, even before I knew, I used that method in structural system where we could achieve a steel consumption of 3.4 kg per square feet. in 27th floor. ISB 20 floors completed in 20 months with the IGBC gold rating. We did this project also, construction, and phase 3 we completed DPR, and now construction is going on. And here the consumption of steel for 15-story rigid monolithic construction is 3 kg per square feet. Very economical optimum system. And this is another project, not very optimum. This is also conventional project, 2 million square. Here we have used rigid monolithic construction first time in Hyderabad in 2006. This also rigid, first PT monostrand. And 950 rupees per square feet we did about 10 years back, of course. And this is the high-end villas in 13 acres, 36 villas we are doing. And Happiness Hub now, this is there in the podcast also. Construction is going on for these projects. So these are all the projects we did. Whatever I talked is out of the experience I gained from these projects. So I owe a lot to them, sloped roofs. And this is a precast R&B office in Hyderabad, Vijayawada, where we did the peer review of the design for precast and foundation, pile foundation design. So these are all Dell project completed in 6 months in 6 lakh square feet. And our AP Secretariat, which is completed in 6 months, where we did the first design build lump sum contract with the technology neutral. That means in the same project, different technologies are used. We have prepared the DPR and design of architectural, structural MEP, bidding, and assembly, AP assembly also. And this is an auditorium we did in 60 days. So time, I'm showing some of the project. And this is the commercial building, 8-meter span with the 180 mm slab thickness with PT we have done. And this is IT building and the precast Veda Pathsala we did in Hyderabad. And this is the precast hostel building in Hyderabad we did. RCC precast only. 12 months it is completed, 2 lakh square feet, 10 floors. And this is a Vijayawada again, Jakkampudi precast platted industry. It's a multi-tenant building. It's all done in precast. Of course, this is the flat slab system and pharma industries in RCC building. This is a commercial building, BMW showroom, and all simple building. Snow World also in the same project we did RCC, post tensioning and composite deck. First time slab without reinforcement. We have used the polypropylene fiber and deck sheet on the roof actually. There is no reinforcement. Lumini, laser, and the school buildings and college buildings and engineering college, Delhi Public School in DPS world. And PB structures in northeastern region, 22-meter retaining wall with reinforced concrete in earthquake zone 5. And this is the latest one going on in Neoma near Leh Ladakh, Galwan Valley, near Galwan Valley. Is about runway and all facilities we have done. So finally, I'll conclude. So India is leading in terms of volume of construction and of also implementation of technologies, latest technologies actually. This is a very heartening to note. We engineers in India are delivering the latest technology projects. Professionals, researchers and academicians to be updated on the trends and upskill all the stakeholders. This is my aim and this is the reason why I accept anybody asking me to give a talk, because I have some international conference exposure and I am also in committees of our codal revisions that are happening, including NBC, and codes and standards must be updated to formalize the practices. Whatever I talked, most of them are not in the code. Actually, I have come across IIT professors asking me to show the code why I am using a ribbed floor like that. So we have to have come out with the manuals of practice so that they become the code of practice as we move forward, and ratify the methods being adopted by the industry. So this is the very, very important thing. So we have to work for it as engineers. So I look forward to all your support for achieving these objectives. And And I thank our friend Durga Prasad and Guru Garu, Badam Sundarao Garu, for giving me this opportunity. And all these talks, whatever I am explaining, are available in my YouTube channel in my name, Kannada Surya Prakash. So anytime for anything, you can visit. There are 270 videos in my channel. This is documented to help our fellow engineers and future engineers who need not reinvent the wheel that we have adopted already. So thank you very much.
Thank you, sir. You covered a wide range of technologies, including their castings for a few of the technologies with a showcase of your product, your projects done. Now I invite Dr. Badam Sundara Garu to conduct the question and answer session.
First of all, thank you very much, Surya Prakash Garu, for your excellent presentation. Within a short time, you have given a very good exposure to different types of construction methods, sir. Thank you very much. And now I invite the members and participants to raise their questions.
Hello. This
Yes,
is
sir.
Surya Prakash.
Yeah.
Yes, sir.
Please, sir.
Yeah. Thank you, Tambi. Surya Prakash. ఎందుకంటే మాకిద్దరికి చాలా సన్నిహితం ఉన్నది.
ఓ అన్నయ్య గారా? ఓకే.
అంటారు
ఎవరో తమిళియన్ అనుకున్నా. కాదు ఎవరో తమిళియన్ అనుకున్నా బొట్టు అది చూసి.
Thank you, Surya Prakash, for your nice presentation and elaboration in the recent trends in the civil engineering aspects. And I hope, and also I request all our fellow engineers in ACCE, IEA, ICA and other fellows to support Surya Prakash in the coming elections so that he may bring some more good changes in our community, engineering community. So I humbly request all the fellow engineers to support Mr. Surya Prakash, my dear good friend, and also my brother, and also my junior, my senior, my classmate. Thank you.
Thank you, Surya Prakash Garu.
Sir, good morning and good afternoon, sir. This is Chandrasekhar.
చంద్రశేఖర్ గారు చెప్పండి.
Sir, I think your presentation is extraordinary and it is very useful to every civil engineer. And you became a legendary in the civil engineering field.
Oh, no, not.
And I think not even a single category you have left to anybody else to do it. Every inch of civil engineering you have covered from top to bottom. By seeing your all the legendary works been admired. Sir, thank you so much, and it is a privilege for us to support you for civil engineering noble cause.
Thank you.
And a small doubt, sir, that what is we are facing nowadays, due to parking maneuverability, as you very well said, in commercial and office spaces, you are maintaining 8 meters and 11 meter spans. But even in a small residential projects with consisting of 2 or 4 flats in each floor, and still plus 5 floors in a category tier 2, tier 3 cities in Kakinada like that. Small projects also, due to maneuverability of car parkings and all, we have to maintain something like a 6 to 8 meters spans, at least. As you very well said, 6 meters also will accommodate only 2 cars, right? 8 meters will ideally place 3 cars. That is how we are designing all the apartments complexes with limited columns in the ground floor. And inevitably and forcibly we are trying to put something floating columns or some stuck columns or staggered columns. We are not happy with the structure. Even it is scolding us how you are doing this and all the grids and all the standard procedures we could not able to follow. Main due to maneuvering effect, we are forced to keep the larger spans and by missing optimization. earlier the structures are very economical and now they are becoming very expensive and costly. But for the staggering of the spans and bigger spans and so on and so forth. And even with the utilization of TDR in AP, the GO is very liberal and now they are allowing even 2 floors. Even in 300 square yards, we could able to put still plus 5 floors.
Oh,
So in a 300
okay.
square yards plot, we are placing 10 flats with 10 cars. Even one flat will not be sold out without car parking.
Correct.
Earlier, when we charge, we are charging for the car parkings. Nobody are interested to take car parkings at extra cost. Now it is a mandatory, like without a main door or without a toilet, no flat can be built. Without any car parking, no flat will be sold out. That is for sure. What is your advice or this, sir, that to maintain the optimization of the structural cost and all?
In fact, yeah, that's a very good, valid question, Chandrasekhar Garu. In fact, what I have done is wherever we do the rigid monolithic construction, even 5 floors, we did rigid monolithic construction in Hyderabad. Now, the cost of shuttering is not a matter at all. So, when we go for rigid monolithic construction, we need not have the transfer slab or transfer girders. The wall itself, rigid and monolithic wall itself will act as a deep beam if we model it properly. And I have done it also, that 15-story building where I have 3 parking floors. In the 3 parking floors, what I have done is the intermediate partition walls I have terminated in the parking level. So we had a 6-meter span for car parking and driveways. And I can share you those plans, what we have actually done, where we could achieve 3 kg per square feet steel consumption, even in rigid monolithic construction for 15 floors. So that is where I have used rib actually. A single-legged stirrup will be there in the rib actually. 100 mm rib I have used as a structural element to stiffen the slab in a typical floor. And in the parking floor, I didn't have a transfer girder or this one. So that is very much possible. I got it approved by IIT and JNTU also, that system with a lot of effort. And I discourage use of these transfer girders and floating columns, particularly in residential buildings. The cost will be very high.
That's what. And there's beams and the beams will be overloaded with the point load and all.
Yeah. That's only precaution is when we go for this system, the props that we have in the parking floor, we should keep it at least up to 5 floor slabs to be completed.
But the formwork
Because there is an arch action. There is an arch action. Only props. We have to keep the additional prop. In one project, what I have done is I did the RCC column in the parking floor. And after completion of 5 floors, I have dismantled the columns.
Okay.
That is also possible.
So you have experimented.
Yeah, that is that. In fact, my contractor was skeptical about the performance of the props for such a longer duration, 2 months or 3 months. Then I said, okay, go for RCC column with least lean column like.
Lean.
And I dismantled it after 5 floors casting.
It's a temporary one.
Yeah, temporary.
And the formwork for the rigid monolithic walls, the formwork is not so freely available here, sir. Means that is not abundantly used here.
No,
maybe expensive.
I have vendors who can supply formwork for pay-per-use. You need not buy.
That's what.
I have developed that vendor in Hyderabad.
Okay.
Indiram Illu, he is doing, sir, 5 lakhs rupees per 360 square feet, individual house in scattered locations. He is able to deliver happily and earn money in that.
Oh.
With aluminum formwork for column beam slab.
So if we could do that and reduce the time of construction with reduced cost of construction.
He delivered those houses in 15 days. There is in Facebook, in YouTube, that video is there. You can see that.
Wonderful, sir.
how the quality has come out.
Sure, sir. Thank you, sir. Thank you so much.
Thank you. Thank you.
My name is Madhav Kamath from Goa.
Hi. Hello, sir.
How are you? Nice presentation. Really enjoyed.
Thank you very much.
I have a question for you. In industrial buildings, if you have a typical, say, 8 by 8 or 9 by 9 meter grids for elevator slabs, where the live loads are very high, let's say 1.5 or 2 tons per square meter, would you, what kind of floor system would you recommend?
Actually, such a heavily loaded slabs, I recommend ribbed floor or voided slab.
Grid floors?
Yeah, grid also is okay. But grid is formwork wise, it is difficult. That's why I suggest voided slab with PVC balls for large span. That will be economical and buildable easily. Co-biaxial system.
You wouldn't suggest post-tension system, I guess.
Post-tension we can, sir, but the problem is large span, the dead weight will increase with
Moment
the slab
reversal. Moment
for
reversals.
that heavy load. Because when you have 1.5 tons punching shear, your slab thickness will go to 350 kind of depth actually, 350, 400. And the execution difficulty and also the cost. So if you go for co-biaxial in 400 thick, it will be a flat plate kind of thing, but at the same time lighter in weight and a flat formwork compared to grid.
What would be the thickness for the comparison, sir?
Co-biaxial.
Yes, sir.
No, co-biaxial also thickness will be 400 only. We use 9-inch dia balls in that.
Okay.
16-inch slab.
Dead weight of the slab.
Yeah, dead weight will be reduced drastically and formwork will be flat only.
Okay.
Can I ask one more question?
Yeah, please.
In one-way ribbed slabs, do you need shear reinforcement generally? I suppose you will need it near the surface.
Yeah, as I mentioned, in the rib you can use a single-legged stirrup. I have done it. Not double, two-legged. It is a single-legged stirrup.
Yeah, I get you.
Yeah. We have to check for shear, like T-beam. Like a T-beam, we have to check for shear.
Naturally.
Hello, sir.
Hello, Nasuragar, please ask your question, sir.
Right. Thank you, sir. Very nice presentation, sir. This is Prakash Yadav.
Thank you.
Will support you definitely for your good cause. And I hope
No.
interactions.
Let's not mix technical and political. I'm today focused on technical.
We have some interactions regarding this. You have rightly said that the upgrade concrete technology will be helpful to reduce air pockets in the concrete. Yeah. Besides that, my opinion is we have the advantage of this the prevention of the segregation of the concrete also. Whenever we are doing the concrete from the top to bottom, the permissible lift is only 1.5 meters. And most of the practical cases we are avoiding and we are not following that practice also. Due to that,
actually, Narsimrao, we have overcome the segregation issue with flow mix design or using superplasticizer. But only challenge is air bubbles, air pockets that we are overcoming with upgrade.
Yeah, for the normal side concrete, that is one of the issues, sir.
Yeah, that's right. Without plasticizer and without flow mix design, you will have the segregation issues.
Fine. And one more question is regarding this foundations point of view, consider it as a fixed and the opinion condition, you rightly point out that. But we should not follow the rule of thumb in all the cases. We have to consider the radius of the relative stiffness in the case of raft also. If the draft can be a flexible draft also, other it can be rigid draft. Accordingly, we
That's
have to
right.
model it. And one more thing I want to highlight is nowadays we are using the single files also, sir. In that single case of files where we are using, there is a possibility of field connection also for the file population. The general assumption, as you said, is a fixed base condition. And for the based upon the structure, how we are adapting, that should be taken into account.
That's right. In the single file, particularly if we don't have the tie beam at that level, definitely moment becomes a big critical thing and shear. And the depth of fixity will increase drastically. So it's better to have tie beams when we have a single pile, not just isolated cap.
If you permit me one more interaction with you, sir. Regarding while considering the hybrid structures like what we are using the dual systems and all that, the interaction between the two systems is very important in terms of the behavior-based behavior in terms of the bending moments and shear, and also how they were inflecting at different points towards the height of the building. That should be addressed by the structural engineers. That I want to highlight from your side.
Correct. I agree with you. Dual systems already IS code has given the method to be followed, and we have to follow that.
Can I come back?
Yes.
Yeah, Madhavji.
Have you done any project with structural lightweight aggregate concrete and steel frames, steel beams?
Steel beams and structural, no, lightweight aggregate we have not done in structural, sir. Only for what you call weatherproofing course we have used lightweight aggregate. That is for temperature control.
Not structural concrete.
Not structural. Still not in vogue.
Okay. Because we are planning to use for a project now in Goa, and we are still.
Please back it up with tests, sir. Shear and
yes.
Yeah.
We'll
and
have it tested.
in fact, I want to intervene. Some people have asked in the chat box about drop panel and column capital, column head. Actually, I want to clarify. Drop panel is nothing but as given in IS 456. It is 1/3 of the span will be the drop panel size. That is used to reduce the overall slab thickness actually. And normally for 11 meter by 13 meter, we have used a drop panel of 275 mm in addition to 230 mm thick slab. So this is the data. And when we use column head or column capital, we can use column head or column capital without drop panel or with drop panel also. We use the column head capital to reduce the thickness of the drop panel again. So column size, if it is smaller and if the thickness of drop panel is getting more where we have heavier load, in industries we have used that drop panel with column heads or column capital. So this is for the chart box answer.
Good afternoon.
Yeah, Bhagavat, please.
Yeah, hi sir. Recent last 5 years I'm following in your LinkedIn actually. I have 10 years experience. Currently I'm working in WT Cost Advisory as a senior cost advisory in the tendering department.
Okay.
There is a few of questions to you. One is that I am worked for one of 40-story building around last 2 years back.
Okay.
There is a one question because of the 6 basement excavation. There is a certain excavation has been laid additional because of the heterogeneous of rock types. There is a 2 to 3 meters additional excavation has made by the contractor. It's not his mistake. Whatever the methodology adopted by the contractor, it has went wrong. But whenever we are in the post-contract stage, we observe that there is a certain plumb concrete needs to be filled, which is costing around 4 to 5 years to the client. Client asked us the cost consultant a question that why cost consultant has not suggested any kind of lowering down the foundations kind of questions to us. It's the experience to me directly only. There my answer is that in my civil engineering field, I didn't study that kind of lowering down methodologies can be taken place by the cost consultant kind of thing. Like I want to understand whether my answer is right. Either it needs to be done through the structural engineers.
No, definitely you have given the right answer, because cost consultant's job is to arrive at the cost for the given thing. You are not optimizing. Value engineering is the job of a project manager, project management consultant, or civil and structural consultant. That's why I said in the beginning, civil and structural consultant. If you have
Yes.
hired a structural designer alone, also it's not his responsibility. If it is
Yes.
civil guy, civil and structural consultant only can solve this kind of problem.
The second question is that, sir, you mentioned about the creep and like the cycle period of the slabs and everything. Like if a vertical elements is constructing alone without dependency of the slabs or the composite structure core walls also. I'm not getting that answer, that what is the creep load considering for the cycle. If I monthly five cycle cost, five slabs cycle cost we are considering, you are taking the priority of the like a grading, high grade of concrete. If we go means we will not that reap disadvantages kind of thing you mentioned in the earlier slides. What exactly, like you mentioned, give me the clarity, sir.
Actually, creep is nothing but early deformation before the concrete attains its design strength.
Yes.
Okay. Normally we take 28 days strength. So 28 days strength considered is M30, suppose, let us say. And if you load the column to that design load before 28 days, then it is subjected to creep actually. So to compensate that creep strain in the column, though the design grade is M30, you have to use the grade of concrete which gives that capacity in 7 days, 30 M30 strength. That means 30 by 0.6 is about 40 M50 grade concrete. So if you use M50 grade concrete, you can compensate to some extent that creep actually.
Okay. It means to say it's already higher designed one, so there is no issue on the like
No,
cycling
strength.
period.
Ultimately, strain
Okay.
is linked to the stress and strength, you know. So that strength, you have to have the required strength for the design load. If you are achieving the design.
My third and final question, sir, like I'm dealing the tendering aspects of the multiple general contractors. I observe that you people also making the tender technical documents and everything to awareness to the bidders. Now I observe like it is a 5,000 cubic meter of the core raft we have been casted for our project. But there is none of the detail related to temperature control concrete has been published in the bid documents.
Actually, that is the job of the quality guy. Whenever you are using mass concrete, in fact, we have designed the mix in minus 30 degree climate. We have designed the mix, and we have designed the mix in 50 degree temperature raft also. So in 50 degree temperature raft, we use the ice cubes, and in minus 30 degree raft, we use the hot water
So,
in the concrete mix.
Yes, clear question is that giving clarity to the bidders, like as a structural consultant who is designing that it is
Again, my point is civil and structural consultant.
Yeah, correct, sir. Civil and structural consultant.
Only structural consultant doesn't think of mixed design.
Yes,
You will only specify what is the mix required.
Yes,
it is the responsibility of the project manager, consultant to decide the mix design.
But it is correct only considering the pre-contract stage, whatever the design deliverables done by the design team, the bid document is developed and issued to the bidders. They didn't know that what is the process, what is the timelines to construct, achieve the raft to as a temperature control concrete. There is a certainty a gap is forming because not giving clarity on that. If you're coming to general QS, everyone thought that it is M50 only. It's not the temperature control.
Though you are young, you are really thinking in the right direction. I'll tell you, we still have people, employers, who think that structural design and project management, if it is done by same company, there is a conflict of interest. But that is wrong totally. In fact, it will help the project if you have. That's why I promote the concept of design, engineering, and project management consultancy. That means the single agency should take the responsibility. And I have done the projects where I am penalized for any variation, not increase or decrease alone. Any variation in a
Okay.
given section, if it is more than 5% of the cost, a consultant, DEPMC consultant is penalized. We should encourage this. We are seeing, and you see the Nitin Gadkari's comments on DPR of late. I also replied in the LinkedIn saying that it is, if you employ DPR consultant separate, project manager separate, design consultant separate, EPC contractor separate, who takes the responsibility ultimately at the end of the project? It should be the client, because you are speaking for 4 roles. If you combine all 3 roles at least to get the contractor in place, then the consultant will take the responsibility. He is accountable. In fact, that is my life mission, to make engineers accountable for the cost, time, and delivery of the project.
Excellent.
Only Engineers Act will help in making engineers accountable.
Yes. In the final question, one is pending, sir. You mentioned that like methodologies needs to be mentioned in the process. Did we are in the bid process? We are mentioning that methodologies, either like what happening in the current market is the post awarding of the works only methodologies is developing by some area, and it is approval getting in the 3 or 4 days, and no one is. I
And
think
that post facto is leading to corruption, actually, if you know.
Yes, sir.
I give the methodology that suits me, that I can, with which I can trouble the contractor. So it is always better we specify the methodology along in the technical specification.
Correct, sir. Sir, I think you covered most of the points to cover structural and civil engineering aspects also, which we are also so encouraged to learn from you. This is very great opportunity to have in this meeting.
Thank you. Thank you.
Surya Prakash, can I speak?
Sir, namaste.
Namaste. Surya Prakash, one thing, by combining performance-based design with top-down construction, builders can create high-performance building while streamlining the construction process. No doubt it is. But while performance-based design, we have to keep some equipment throughout the span of the building. But nobody is doing that one. Can you concentrate on this particular topic, including performance-based design and equipment, and also top-down method? So nobody is speaking about this separately. You can conduct this. You know, from last 50 years, I'm doing consultancy, but from last 25 years, I have become a student, because once I attend your seminar, 1 year I can need not read anything.
Thank you, sir.
And the last 15th of September in Hyderabad, people awarded me eminent engineer in front of you. I am very happy for that.
Yes, sir. Yes, sir.
You think about this performance design
Sure.
and top-down method. Okay.
Sure, sir. Thank you, sir.
Right. Okay. Thank you.
There are some questions in chat box, sir, at the starting.
Yeah.
Sir, in your presentation, you told that you have designed 11 meters by 13 meters flat slab with drops. Is this
Yes.
system is suitable for earthquake zone 3 also, sir?
Yeah, I missed that point, sir. We have designed in Delhi also, sir. Zone 4.
Okay.
We have designed, but only thing is, when we go for post-tensioning, for the lateral loads, post-tensioning cannot be considered. It should be reinforced concrete one.
Yeah.
That we have done, sir.
Yes, sir. That's my question, sir.
And some people, sir, very important, I want to clarify. Some people, even my own design engineers, questioned me, sir, when we are using 16700 code, high-rise building code, they are telling we cannot use rigid. There are some blanket statements in the code. You should not use post-tensioning in zone 3. You should not use rigid monolithic. Like that, some damaging blanket clauses are there. In fact, because of that questioning, in Hyderabad, we organized a meeting with the code committee members. In fact, if you see the preamble of the code, it clearly says the responsibility of the structural designer decide judiciously on the structural system to be adopted. So, if we take care of these aspects which I am telling, then definitely we can use any structural system if we are designing properly. So, this is for the benefit of engineers who are designing high-rise buildings with the 16700 codes.
Yeah.
Sorry.
And one more question is from, I think, Pragati student with roll number J0112. What is
They are students.
Yes. What is the punching failure at flat slab, sir?
In fact, one should refer to a book by Dr. Purushothaman, sir, who has clearly explained the concept of punching shear with the sketches, actually. So, I think I have shared it in one of my presentations in my YouTube. You can refer to that, or if you can message me personally also, I'll share that information, sir.
Yes. And from the same person, another question: what is the meaning of column capitals and drop panels in flat slabs?
Yeah, a drop panel is we are dropping the thickness in the locally around the column as per IS 456, where as per the code, drop panel size should be 1/3 the span. That means if you have 11-meter span, the drop panel size will be 3.8 meter by 3.8 meter. And it can be rectangle also sometimes, and it can be eccentric also, drop panel. And that is called drop panel. The panel of the flat slab is dropped locally around the column. That is the meaning of drop panel. And the column head or column capital is near the column. We have column head can be inclined also, trapezium shape or conical shape. And column drop is a rectangular prismatic thing, rectangular or square shaped panel. So these are available in textbook also and IS code also. And I'll share from Purushothaman if you want the specific pages explaining clearly about this concept.
Yes, sir. Please.
Hello, sir. Hello, sir.
Yeah, Sharad Patil.
Yes, sir. This is Sharad Patil from Malpani Group, Pune.
No.
Yes, sir. We are constructing IT park and commercial building in Pune. Currently, we are working with J plus W and WWP consultant. We are constructing 15 lakh square feet, 20 lakh square feet IT park, and we want to schedule our RCC work in 600 days or in 700 days. What technology shuttering metal we need to use to complete the 20 lakh or 15 lakh?
How many floors?
It's 96 meter height. It's a 21 storied commercial building.
21 storied in 2 years, huh? Or 600 days?
600 days or 700 days.
Yeah, we can use drop head system, flat slab if it is designed flat slab, or if it is engineered form work, we can use table form. Table form also will give you faster timelines. And mainly the challenge is when you have large area, it is the resource leveling is the main thing that is required. So you can reduce the cycle time, at the same time do the resource leveling by splitting into staggered casting of the slabs actually.
Casting as making the areas in poles, no?
Yeah.
Yes, sir. Sir, is it possible to give the guest lecture for the Malpani Group engineers in Pune?
Actually, I'm doing a project second time in Pune. The table form that I mentioned is for table form in for Tech Mahindra campus, in Hinjawadi.
Okay.
Now also we are doing one extension phase 3 for same Tech Mahindra.
Okay. Is it possible, sir, for you for the guest lecture?
Yeah, let us connect.
Yes, yes, we will connect. Yes.
If you have noted my number, you can message.
Yes, yes, I noted, sir. Okay. Thank you, sir.
And one more question from the same student, sir. What method will be used to support the drop head during the concrete pour to prevent premature collapse or deformation?
It is the same formwork we use. There will be a step in the form, like for the drop panel or drop head. Actually, drop head, if it is drop head or column head, it is casted with the column only. Or sometimes we cast along with the drop panel, the formwork. The box is designed. Unfortunately, I don't have the picture right now readily, but I'll share with that student if he is messaging me separately, sir.
Yes.
I've given my contact number.
Yeah. Yes. And that's all, sir. And any more questions from the participants?
So
Can I
think-
conclude?
Yes, sir. Please conclude, sir.
Yeah.
Yes, sir.
Sir.
Please invite Mr. Sivaram Krishna for his vote of thanks.
I request Sivaram Krishna to say vote of thanks.
Okay, sir. Hope he gone for his baby's doctor's appointment. I will say the vote of thanks, sir. My first and foremost thanks to our ACCE headquarters for arranging this meeting link for the webinar. And my sincere thanks to our chairman, Dr. Badam Sundara Garu, for give his support in conducting this webinar. My thanks to our ACCA members, ICA Kakinada Center members, local engineers, and senior participants from various places, Mr. Srikant Channel, SP Anchuri, and Kalgal sir. And my thanks to the student participants from Aditya and Prakash Engineering College and their coordinators of the student chapters of ACCE Kakinada. And finally, our thanks to Engineer Surya Prakash Garu for his valuable time on this Sunday time for this knowledge session and sharing his valuable knowledge to our engineers for the betterment of this Kakinada Center. Thank you, sir. With your motivation, only this center is happen and growing like a banyan tree and doing a lot of activities. Thank you, sir, for inspiring us and motivating to form this center in 2020. You and Sundara Garu will done this center in a good position. Thank you all. Thank you.
Thank you very much, sir. Satyanarayana Garu, thank you for being with me today.
Thank you very good lecture, Surya Prakash Garu.
Thank
In
you,
fact,
sir.
I
Thank
wanted
you.
to speak, but a very
Yeah.
nice lecture, and you are guiding so many people from students to practicing engineers.
Yes.
It's very nice of you. We will talk in person now.
Thank you, sir.
Thank you.
Thank
Very
you. All the
Very nice.
happy Navaratri and Dasara to all the people, sir. Thank you.
Yeah, wish you the same. Wish you the same.
Yes.
Thanks, sir.
And all.
If you want to appeal the members, you can, sir.
No, appeal I already done. So I
No,
request all
everybody
of you to
should,
support me.
No
Everybody should,
appeal is
Surya
required,
Prakash
sir.
Yeah.
Everybody
No,
should
no
support
appeal.
Surya Prakash Garu.
We are with you.
You are the most deserving
We'll
candidate.
make the best, sir.
Yeah.
Thank you, sir.
You are the first
Thank you,
first one to be voted by everybody.
Thank you, sir.
Yeah. Wish you all the best.
Okay, sir. Bye, sir.
Bye.
Thank
Thank you very much.
Thank you, sir.
We are concluding, sir. Closing, sir. Thank you.
Yeah.
Thank you.
Thank you, Surya Prakash, once again